Good afternoon, ladies and gentlemen. Ma Li, Sun Wan Singh, Chin Hoots, and Ji Srun. I can see four names in the first screen. Okay, extreme may also function. Chinese guy comprehend not Manitz Watanak. Anyway, good afternoon, guys. One more time. I hope you are all doing well. And as you know, we have been talking about applications of derivatives and particularly what is it, optimization problems in the class, right? We did maybe 2 or 3 questions. So today I will continue. And now today only I want you to focus on applied optimization. Now I'm going to make 2 short videos about Newton's method and antiderivatives. Okay, it's not actually big deal, and I hope by just practicing you can improve your what is it, understanding or skill, problem solving skill involving Newton's method and antiderivative. Okay, and that's why next Monday I am going to start chapter 5. And next week is Khmer New Year. And after that, again, we will have, what is it? I think Khmer New Year from 14th, I think, to 17th. Even Monday is holiday, okay? That's why I'm thinking to give you a quiz, all right? I will actually make a decision tomorrow. Okay, maybe I may give you another quiz next week. Otherwise, will be really too late. It will be too close to, what is it? To our final exam. Okay, so guys, for what is it, for chapter 4, once again, this 4.6 4.7 is not so difficult, just you have to practice. Okay, but especially 4.5, all right, you need to practice almost all the questions if you really want to improve your problem solving skill or get a high grade in your. So actually with the example 1, example 2, we did in the class, but example 3 with the first section, I didn't do that. With the second, actually third sections, right? We did this example. Let's continue from here. Okay, one more time. It will be a practice for you. And I'll try to solve maybe 8 questions in today's class. Okay, so now in this question, if you remember, we are talking about a circular window, and we are going to place, what is it, a rectangle, right? And we want our rectangle to have the largest area. So we have actually kind of rectangle here. It must have the largest area. And the question is saying that if it is so, then what must be the dimensions of this rectangle? Okay, dimensions of this rectangle. That is another problem related to optimization. Now to do this one also, we know that the radius of the circle is 2, right? So let me just, even without introducing, I can do that. It doesn't matter actually. Here, let me just introduce, okay? This one is x-axis, that's our y-axis, okay? Then actually this point, the coordinate of this point, it will be 2 since the radius of the circle is 2, and also this one is 2, and this is our y-axis. This is x-axis, right? And suppose that's actually the length of this part, okay, it is x, okay, and the height of the width of the rectangle, let's say it is y, okay. So then what is the area of this rectangle? It is length times width. So the area of this rectangle will be 2x, that's length, times y, right? So we are going to actually maximize this, right, under this given condition. Now to do this one first, if you remember, first we have to find an equation that connects x and y so that I can reduce the number of variables into 1, so that our area becomes just a function of single variable, since actually we are having single variable calculus. Now if I just connect these 2 points, also it's a radius, it will be 2, right? So at the time here we have this equation that connects x and y, x squared plus y squared, that's equal to 2 squared. Or from here, I can actually find y in terms of x. That's equal to 4 minus x squared. Okay. So then our area then becomes a function of x, where that's equal to 2 times x. And here we have 4 minus x squared. And once again, what is the domain of this function? x changes from 0 to 2, and 0 to is not inclusive. So now we are looking for the value of x in this interval that maximizes this area, right? That means that gives us the maximum value of this a. Now to do this one, we are going to use the first derivative test to find the critical point, because if it has local maximum or minimum in the interior point of this domain, right, it must occur at a critical point of the function. And what is the critical point of the function? It is the value which satisfies this equation, right? The derivative should be equal to 0. Now we have the product of two functions. Let me just keep 2 here. Okay, so here we have x, sorry. If you differentiate x, it's just equal to 1. So here we have 4 minus x squared. And the plus, here we have x. We have to differentiate this function, square root of 4 minus x squared. So that's equal to 1 over 2 times derivative of 4 minus x squared. That is negative 2x times derivative of the root with respect to 4 minus x squared. That is 4 minus x squared to the power of 1 over 2, minus 1 over 2, right? So this thing should be equal to 0. Now we have to solve this equation. That's equal to 0. Now, as you see here, this 4 minus x squared, right? And actually, we know that it's not equal to 2. That means that it's not equal to 0. So if I multiply both sides by square root of 4 minus x squared. Okay, this one is multiplication. So what happened here? Also, I'm just dividing both sides by 2 because I'm just solving this equation. So here we have 4 minus x squared. And this one is minus plus 2 is gone. It is minus x squared, right? And the thing is gone. So that's equal to 0. And now if you solve this equation, here we have 2x squared is equal to 4, or x is equal to square root of 2, right? And now you can check this that actually by differentiating one more time, right? You can see that actually this a double prime of this, what is it, square root of 2 will be, what is it? It is less than 0. It will be negative. Okay, I'm just not going to show this because we have already done the class. Okay, I'm just going to write the final answer there. And since x equals negative 2 and y is equal to, if x equals negative 2, we have also y is equal to negative 2, right? When it is so, the rectangle will have the maximum, the greatest area, which is inscribed in the semicircle. Inscribed means that the corners, right, it must be touching this semicircle. So then what's our answer? Then the length of the rectangle, it must be 2 times square root of 2. And its width must be square root of 2. All right. Guys, this question, I'm not going to write one by one. Maybe if you in the class, if we have more time, we can have more discussion, okay? But still, you know, if you really want to improve or your problem solving skill, I suggest you to do this one more time yourself without looking at the solution. Okay, so this problem is about the speed of light. Okay, how actually depends, it's related to the angle of inclination, or we call this angle of refraction. So the speed of light depends on the medium. Right? Medium means what kind of actually we have environment we have. It is just air or gas or water, or I don't know, it is hot or cold. So the speed of light depends on the medium through which it travels and is generally slower in denser media. Right? For example, through the wall, it travels slower. How about if there's nothing in the air, it travels much faster, slower in denser area. Fermat's principle in optics from physics states that light travels from one point to another point along a path for which the time of interval is minimum, and describe the path that a ray of light will follow in going from a point A in a medium where the speed of light is c1 to a point B in a second medium where its speed is, what is it, c2. That is actually another beautiful, maybe, I don't know, the principle or rule of not universe, let's say our planet, right? And sometimes you will see that, for example, let's say the spider. Okay, the spider, for example, when it sees its prey and it just evaluates the distance and it chooses the minimum path to attack its prey. Or ants in similar way, for example, they communicate with each other actually in such a way that that is the fastest in terms of maybe the distance and everything. Or another example is, what is it? Bees, for example. Okay, now if you're interested, you can watch short video about the bees. When they find actually kind of, what is it, we call this the pollen, right? When they're collecting honey from the flowers, so they have to go back to their, and what is it, to their house, and they have to inform everybody about this. So anyway, for traveling this one, also they are choosing the shortest path. And that's also beauty of nature. I think I'm really amazed about this kind of things. But here we are talking about the light. You see here, light actually, if somebody is standing, or I don't know, you have a kind of torch from point A, right? And this light actually should touch this point B, should reach this B. But actually here we are talking about two different, what is it, environment. Let's say about the ground, for example, we have just air. Under the ground, maybe we have water. Or maybe we have a kind of foggy air, and we have, what is it, kind of soil, for example. Okay, whatever it is. Now here, if I just, what is it, model this from A to B, right? And after that, we are introducing this y-axis and x-axis and labeling the distance between A and this zero, let's say it is A. And from P to point B, the vertical distance, let's say it's B. Okay, then we are talking about this is important for us, this angle theta 1 and this angle theta 2. So we are going to find the relation between how they are related to each other. Okay, so now to do this one, first we have to form what is it, we have to use using the given information. What is it? We know the speed of light, right, in two different mediums. So what is speed? Speed is distance over rate. So in the first case, what is our distance? Distance is AP, right? And using Pythagorean theorem, we can find AP in terms of A. A is given. X, we don't know what is it, that we are trying to find this, right? That is A squared plus X squared. Now from here, if we find, what is it, the times required for light to travel from A to P and P to B respectively. T1, how much time does it take for the light to travel from A to P? Now we know the distance. I don't know, but actually suppose that it's diffracting at point P, and the distance between 0 and P, that is X, right? At the time, T1 will be, it takes this distance over speed, that is square root of A squared plus X squared over C1. And how about the second part? Because of the medium is changing here, so there is a diffraction here, right? We say that it's broken here, a certain angle. So now, how about the time for the light to travel from P to B? So again, it is distance over speed. What is distance? PB. And what is PB? Again, by using the Pythagorean theorem, we can find PB. And the distance between P, vertical distance to B, it is B. And suppose that the x coordinate of B is D. So that is D minus X, right? That's why here we have B squared plus D minus X squared over C2. Okay, so now we can find the total time then. What is the total time for the light to travel from, excuse me, from A to B? It is T1 plus theta. So that's T1 plus theta. We are just adding those two expressions. Okay, so now we are going to find the minimum time, right? Since actually the light is traveling in the minimum time. So now I have to differentiate this T with respect to X, because you see here time is a function of X. What is variable? Here X may change here, right? Depending on the environment, it may change. Now again, actually it depends on your differentiable or differentiation skill. You know, if you have practiced a few questions, you should be really good at differentiating this kind of functions, that we are going to see them a lot in this throughout this course. So if you differentiate the first part, right, A squared of A squared plus X squared, C1 is constant. So that's equal to X over square root of A squared plus X squared. Also here we have C1. And if you differentiate the second fraction with respect to X, we will get this expression, D minus X over C2 times B squared plus B minus X squared. Because we know that here, as you see here, our X, right, X is changing from 0 to D. So these are the possible values of X, right? So at any point, so our X is here, somewhere here, right? So now we have to minimize T, right, to find this one. So we have to use the first derivative test. That means that we need to find the critical point in the interval from 0 to D. I'm just looking for the critical point from this interval from 0 to D. Okay. So now if you just solve this equation, okay, that's why that's equal to 0. Now I'm going to solve this equation and solve for this, and we will get, what is it? This expression dt dx is equal to sine of theta 1 over c1 minus sine of theta 2 over c2. Okay, but how do you know that? Because let's say here in the first one, theta 1, right? Opposite side is x, and the, what is it? Hypotenuse is square root of a squared plus x squared. And that's why here for this expression, I can write, if I need to use something different. So this expression actually is just equal to, this one is equal to sine of theta 1, right? And how about the second part? Is d minus x is divided by the hypotenuse, right? So this thing, the whole thing, this thing is equal to, what is it? It is sine of theta 2, right? So now if I just replace them by sine function, now instead of this x, now we are dealing with theta 1 and theta 2. So here we have sine of theta 1 over c1 minus sine of theta 2 over 2, right? So now here, this must be equal to 0, right? To find the critical point, it must be equal to 0, which implies that now you'll see that then this sine of actually, what is it? Sine of theta 1 over c1 must be equal to sine of theta 2 over c2 for the time to be minimum. Okay, and that's just a kind of, what is it? What we are trying to do here is we just here we want to see one application of, what is it? Derivative, right, in physics, and that's why just to get uh, I said the taste of this application, different brands. Now we are going to see one application in geometry, one application in architecture, one application in biology, one application in physics, right? And that's why you'll have some idea. Now, if you want to go deeper, so you have to practice maybe 2-3 questions similar to this. Okay. Now, another example from economics. So in economics, suppose that you have a kind of factory and you are producing, what is it here? Let's say you are producing some kind of orange juice, okay? And you are producing orange juice in bottles, okay? And that's because it should be countable. It may not be countable, actually. Anyway, we are, what is it, selling orange juice in bottles. So then let me just label the revenue from selling X bottles of oranges by R, right? You are producing, let's say, over throughout the year, in 1 year, you actually sold maybe 1 million bottles of oranges. Now, to produce this many orange juices, right, you need to spend some money for electricity, for, what is it, for the factory, maybe for rental fee, for workers, labor fee, right, and a lot of expenses. Together, let's just suppose that we can model this by function C of X. So C of X represents the cost of producing X items here. Now, what is our profit now? The difference between the revenue and the cost, right? Just as roughly, we are not including every parameter here, right? In 1 year, for example, your income is, let's say, $1 million, but your cost to do this one, you spend, let's say, $800,000, right? The difference, $200,000, it will be the company's profit, okay? So let's label that profit, okay, as the difference between revenue and cost, that is profit from producing and selling X items. Then at the production level, producing or yielding maximum profit, marginal revenue equals marginal cost. Okay, actually in economics, this derivative of revenue is called marginal revenue, and this derivative of this cost function, it is called marginal, what is it, cost. Okay, so now to do this one, we know that if we are talking about this function, our profit function, that is revenue function minus cost function, right? How can we maximize our profit, right? To maximize this profit, again, we need to find the critical point, P prime of X, that is R prime of X minus C prime of X. So this should be equal to 0, right? And if it is equal to 0, that means that we have to solve this equation. They're equivalent to each other, right? So now if I solve this equation, that X, right, the number of items, it gives us some idea where we can have maximum profit or minimum profit. Okay. One example for this, suppose that R of X equals 9X. This revenue is modeled by this equation. Maybe, let's say, your revenue is maybe one bottle of, what is it, that oranges is, let's say we're talking about oranges, that is $0.9, right? If you sell X items, your revenue will be then 9 times X. And maybe it's not whatever it is. Maybe you're selling in 10 pieces in a box. So, and how about the cost? Let's say the cost of the cost function is modeled by this function, x cubed minus 6x squared plus 15x, where x represents millions of MP3 players produced. So in this case, you're talking about MP3. So is there a production level that maximizes profit? If so, what is it? Okay, if so, what is it? So now to do this one, again, we are just using the idea of, what is it? That's differentiation, right? So now first we have to find our profit function. What is profit function? It is revenue function minus cost function. So revenue function is, it is 9x minus our cost function is x cubed minus 6x squared plus 15x. Now, if you just simplify this, okay, if you just simplify this, here we have minus x cubed and minus this plus 6x squared, 9x minus 15x, that is minus 6x, right? So now to maximize, right, first we have to find the critical point. So number 2 is, what is its critical point? So this p prime of x is equal to minus 3x squared plus 12x minus 6. So this should be equal to 0, right? By solving this quadratic equation, we can find the critical points of this function. Therefore, let me simplify further, because all these numbers are divisible by -3. Divide by -3, it is x squared minus 4x plus 2. That's equal to 0, right? So now I can just write it as a perfect square. I have more space, that's why let me just write it to here, continue from here. So now I can write it as x squared minus 4x plus 4, right? So plus 4 minus 2, take 2 to the right-hand side. Here we have 2. I'm just going to solve this by using completing the square method. So here we have x plus 2 squared. That's equal to 2. Then what are the possible values of x here then? x1 is equal to square root of 2 minus 2. And how about x2? That's equal to minus square root of 2 minus 2. Right? Okay. So now from here, see here the second part, right? It is negative. So since actually we're talking about the, wait, both are negative. Why negative? Divide by, okay, by 2x squared minus 4x plus 2. At 2, here we have, okay, here it must be minus 2. So minus 2. Okay. All right. So here we have square root of 2 plus 2. The second one is minus square root of 2 plus 2. Yeah, both are positive here. Okay. So now, how do I know that which one actually maximizes the profit, which one minimizes the profit rate? So now maybe approximately, okay, but approximately we can just evaluate this, and we know the square root of 2 is 1.4, right? So approximately 3.4, and this one is approximately equal to 2 minus 1.4, approximately 1.6, right? So just because I want to know if the second derivative of this test, I mean, this function at these points, they are positive or negative, right? I just need a sign. That's why I can just use this rough estimation. So now next step is change the color here. Say this 1, 2, let's say it is 3. Okay, so p double prime of x is equal to, if you differentiate one more time, that is minus 6x and the plus 12, right? So that's equal to, let's say minus 6x minus 2. Okay, so now the first case, p double, what is it, 3.4. Let's see here, if I substitute 3.4 here, 3.4 minus 2, that is negative, right? So that means that here negative means that it looks downward, right? It's concave up. So here we have maximum value. And how about the second one? P double prime of 1.6, that's equal to minus 6, 1.6 minus 2. It is positive, right? So at this point, then we have minimum profit. So now the question is asking that is there a production level that maximizes profit? If so, what is it? So our answer would be yes, right? And producing approximately, or to be exact, that's just why it's in millions, right? So 2 plus square root of 2, so that's equal to 1 point. Let me just correct the three decimal places. 414 million of, or okay, let me just write here, when x equals 3.414 million, actually, what is it? The P profit will be maximal. Anyway, so our answer to this question is yes, we have a production level that maximizes the profit. What is it? When actually the company produces 3.414 million pieces of MP3 players, right? Then they can have the maximum profit. And how about the minimum profit? Minimum profit is if they produce 1.6 million, right? At the time they have minimum profit. That means that to have more profit, so they need to what is it? Produce more and more, not more and more. Actually, between 1.6 and 3.4, right? As they produce more and more, and look at the graph, of course, we can see that. And also the what is it? The profit increases. Guys, now we are going to solve questions from exercise 4.5. I have selected a few questions, okay? So let's just start now, maybe one question, and after that, after the break, we will continue the rest. So I want to start with the easiest question. I think I choose how many? Maybe 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8, I think. Okay. That's one more question, then we'll have break, okay? Mathematical applications. Whenever you are maximizing or minimizing a function of a single variable, we urge you to graph it over the domain that is appropriate to the problem you are solving. The graph will provide insight before you calculate and will furnish a visual context for understanding your answer. Nowadays, of course, by just drawing the graph, you can see the maximum and minimum value. Now, just we have to verify this by algebraic calculation, right? And maybe you can draw your graph using some kind of software, for example, Graphmatica. And looking at this, you can do your algebraic calculation to verify your results. Because just knowing is not enough. Also, you have to be able to verify or to convince other people by offering some logical statements, right, or steps. In the first question, it says, what is the smallest perimeter? What is the smallest perimeter? What is the smallest perimeter possible for a rectangle whose area is 100 cm squared? And what are its dimensions? What are its dimensions? So we are talking about kind of rectangle. Okay. Okay. So it says this length and width, right? In the question, it says that length is equal to, area is equal to, but we are dealing with the function. I think I better write them as x and y. So let's say this x and y. And also L and W is okay, but usually L and W, we use them for fixed numbers, right? So the area is x times y, that's equal to 100, right? So what is the smallest perimeter possible, right? So what is the perimeter? Perimeter of the rectangle is 2 times length and plus width, right? Now using the first equation, I can express either x in terms of y or y in terms of x. But traditionally we just use actually x as our independent variable. So y is equal to 100 over x. Now if I just substitute here we have 2x plus 100 over x, right? So now we have to minimize this perimeter. Okay, so to do this one, the first step, second step, again, we are going to use the first derivative test to find the critical point. So p prime of x is equal to, here we have 2, and x that's equal to 1. And how about 1 over x, right? X to the power of -1. -1 comes to the front. So here we have minus 100 over x squared. So this should be equal to 0. Now, if you solve this equation, right, both sides divided by 0, so we will get here that what is x is equal to 10. If x is equal to 10, and also y will be 10, right? So now, so what is the smallest perimeter possible? Now we can just write here, p perimeter minimum is when x is equal to 10 and y is equal to 10. That is 20. And what are their dimensions? Dimensions are length should be equal to 10 and width should be equal to 10, right? And actually check this, right? If you just make, for example, the list here, here we have L and the W, right? So the area is 100, right? What are the possible, just for whole numbers, let's say 1 and 100, right? The area, or 250 possible dimensions, or 425, or for example, 520, right? In each case, if you find the perimeter, in the first case perimeter is 202, right? Second one, it is 52, 104, right? And third one, what is the perimeter? That is 29, that's equal to 2958, right? And next one is 5 plus 20, that is 50, right? So here we can continue. So among them, what is the smallest one? What is smallest if length and width, they are equal to each other? All right, another question. I think we have time. Okay, other question a bit long. That's why let's solve one more, then we'll have break. So another question, show that among all rectangles with an 8-meter perimeter, the one with largest area is a square. Okay, so here we have rectangle. Okay, suppose it's rectangle. The perimeter is 8. Right? So that means here, if we have x and this one is y, what is perimeter? It is 2 times x plus y, that's equal to 8. Or immediately I can express y in terms of x. What is y? Y is equal to 4 minus x. Okay, so now it says that we have to show that then the largest area is a square. So what is the area? Area is equal to x times y. And x times, what is y? It is 4 minus x. Or it is 4x minus x squared, right? Now let's find actually the maximum or minimum value of this function. So a prime of x is equal to, here we have 4 minus 2x. That's equal to 0. When is equal to 0? If x is equal to 2, right? If x is equal to 2. If x is equal to 2, and also y should be equal to 2, right? Y also should be equal to 2, right? Now, how do you know that actually it gives us the maximum area, what is it? Maximum area. So now if you just differentiate one more time, right, here we have that's equal to -2. So that is, what is it, less than 0. Less than 0 means that our curve is concave down, right? So at this point, it has maximum value. Okay. Let's have a break, okay? At 3 o'clock, we will continue. And we'll solve maybe 6 or 5 questions. And that's all, I think, for optimization. Okay. See you soon. Suit logo high. 10 plus 10 times 240. Okay, I'll correct this one. 40, right? Thank you. It is 40. Right. Guys, we will continue at 3 o'clock.